Hey everyone, welcome. My name is Sam Coates from HIT Contracting. I'm broadcasting today from our CoLab facility, which is our state-of-the-art research facility outside of Washington, D.C. Thank you for joining us. We're here today to discuss net zero energy targets. Jurisdictions across the United States have set high standards and imperatives on the AEC industry to really deliver higher performing buildings for our clients. So during this broadcast, we will discuss practical opportunities and challenges in leveraging renewable energy production and storage as it relates to net zero buildings. So some quick things on today's agenda. We really have this event split into two parts. The first is some background on the market changes driving renewable energy and net zero. And then we'll have a really engaging panel discussion with our AEC partners across the industry. And then we'll close with a Q&A by you all, the audience. Some learning objectives for today. Why are we here? First is really to understand the opportunities in renewable energy production. Second is to discuss some of the regional variations in net zero readiness. And then finally, we'll dive into some of the market trends that are driving alternative energy across the US. So some quick housekeeping notes as we get started. We really encourage you all to engage in this discussion. Feel free to enter questions in the chat on the right-hand side of your window. You can enter them throughout the broadcast, and we'll address them at the end. Second is that, as you probably know, you've all been placed on mute, so the chat is the way you can chat with us. And then, yes, we will record this and share it afterwards. But as is customary, I wanted to take pause for a safety moment. And since we're all in a virtual environment right now, I wanted to touch upon data breaches. We know that 80% of data breaches are a result of poor password or strength or reusing. So 4 quick tips on passwords. First is to assess your passwords. Do you use them for the same accounts, which I'm definitely guilty of? Do you prioritize the most important accounts, like your bank or your home access? Can you manage updating ongoing basis these passwords, and how often can you update them? And finally is to set reminders. Should you do it on your birthday every year or at the beginning of every year? So that's just a little bit about cyber and password security. By way of introductions, I want to first introduce our panel, who will be joining us virtually here in a minute. But we have Roger Chang from Burl Happold, Anika Londerloo from HOK. We have Michelle Amt from BMDC Architects, and then myself, Sam Coates, with HIT Contracting in the research group. And I'll let them do a little bit more introductions on themselves when we get to the panel portion. Before we discuss renewable energy and net zero, let's have a look at some of the market forces that are really driving changes in renewable energy technology, both across the globe, but specifically here in the US. So, first here in the US, there's a lot of policy changes that point towards a really significant and renewed focus towards renewable energy. The first, as a lot of us are familiar with professionally, is the US infrastructure bill, which earmarks roughly $73 billion in improvements to the energy grid infrastructure, which will be able to support some of this renewable energy production coming online. In May, the Defense Production Act was invoked for EV battery materials in the US, which really encourages innovation in battery and long-term energy storage, which we're going to see impacts in the built environment. And then finally is more local. With the new state energy and city energy targets, we know that 6 states have 100% renewable energy portfolio targets that come online between 2032 and 2045, which is exactly why today, this topic is really an imperative to discuss. There's also a lot of economic shifts happening in actually the renewable energy technologies themselves. We know that since 2010, the price per kilowatt hour has dropped nearly 80% for solar. So it's becoming cheaper to actually produce this alternative energy. And then finally, when it comes to installers, traditionally we've seen our West Coast lead the market in installation and price competitiveness. But we're seeing some changes in legislation, for example, in New York, that are really making the East Coast installers and market much more competitive as well when it comes to solar installations. And then finally, I think all of this really trickles down into the actual cost of producing energy. If we look at the implications, we see that renewable energy generation technologies are cost competitive or even better than some traditional methods like coal, with wind and solar really leading the way in that cost competitiveness. So now that we have a bit of understanding of what's driving these changes, let's dive into some details and look at the technologies and innovations that are actually supporting this change in the U.S. market. So earlier this year, we partnered with Burl Happold to conduct a secondary research study of the available and emerging technologies for on-site renewable energy solutions and technologies. The scope of this was really to do the secondary research and collect case stories of applications. And moving forward, we're actually going to be testing some of these on-site alternative energy solutions here at the CoLab building to really understand what the actual day-to-day implications are. The second scope of this study was really looking at the life cycles of energy. So if we think about a building, we have to think about everything from the production of energy to the recovery of that energy, to some of the carbon capture technologies, to the distribution, how does it get distributed within a building, and then finally to the storage, how do we store excess energy. And so for each of these life cycles, we identified existing and emerging technologies. And I also wanted to take pause and just level set and talk about net zero readiness. All of these alternative energy sources are really in support of net zero goals for buildings. And net zero, at the most basic sense, is really a building with net zero energy consumption by use of the building. So basically what this means on an annual basis, the amount of energy that a building is producing is equal to the amount it's creating, either through on-site production or off-site technologies or credits. So in this study, the kind of final outcome, if you will, was the identification of over 21 technologies available across those 5 life cycles, from production all the way to storage. And we looked at everything from some of the more traditional technologies like wind and solar to some more lab scale technologies like battery storage and concrete and green hydrogen. And so with that, now that we have some kind of context, I want to introduce our panelists. We really think this conversation requires all of us. So we have representation from architecture, building performance, and engineering today to really just have a practical discussion on what this means for us. So we'll have them pop up on the screen and we'll kind of start a conversation. Hi, everybody. Welcome. So to start off, if you can maybe briefly go around and introduce yourself and your role within your company. Roger, why don't we start with you? Yeah, sorry, 1 second, if you can pause. Sorry about that. Doing our audio here. All right, I think we can hear you now. Go ahead, Roger.
Excellent. Well, it's great to be here. Thanks, Sam, for that intro. We're an international firm of about 2,300 with over 30 offices. We've really been honored to be able to work at many different scales on decarbonization, from campus master plans to even developing New York City's 80 by 50 plan, which calls for 80% emissions reduction by 2050. Really looking forward to a discussion with some of my fellow colleagues in the industry about this really important topic.
Great. Someone want to go next?
Sure. Anna Calandrino, HOK, Global Design, Sustainable Design Director, working on projects, various sectors and scales, both in the United States and internationally. Also working currently with DC on our decarbonization code. That's an electrification, but also EV charging and renewable energy on-site code, and I work with DC and other jurisdictions on building energy performance standards and other post-delivery building policies, and work on model building codes as well. So really excited about this sort of upstream, downstream alignment on our global climate policies.
And Michelle?
Hey, my name is Michelle Ampt. I'm with VMDO Architects here in Charlottesville, Virginia, and we also have our VMDO DC office. We work on a range of educational clients and typologies from K-12 education to higher ed and athletics and community studio as well. We're well known for our net zero work in the DMV area with about 500,000 square feet of zero energy projects in that zone.
Great. Well, welcome everyone. We really appreciate your time and excited to have kind of these varying perspectives at the table today. I wanted to kick it off with a very basic question because you all live and breathe this every day. I wanted to ask, how are clients really being proactive towards net zero and energy reduction goals? And maybe where are some of the hesitations? Maybe we can just kick it off there. And we can feel free, anyone can jump in here. We'll pass the baton around.
Well, I'd say even as far back as 2008, I remember finishing up a LEED Platinum building with a client who said, well, that was easy, which was flattering. I said, I'm glad we made that easy for you. But what's next? And I said, well, net zero is the next thing. And exploring different ways to get to net zero. And they were even interested in biofuels. And I think at the time, there were limited supply chain, limited sources. And so I think there were more constraints 14 years ago than we have now. I think there's some constraints with, lot line, zero lot line projects and tall buildings if you don't have enough roof area for on-site solar and things like that. But I'd say it's a steady increase. There's both, as designers, we're asking our clients, have you considered this? And our clients are asking on an increasing basis, is this something we should or could consider? But I think a real trigger came a couple of years ago when Chairman Larry Fink of BlackRock issued a letter to not just their shareholders, but to the organizations they invest in and said, we're no longer interested in investing in you if you're not on a zero carbon trajectory. And I know some of our clients who are doing deep green projects turned to us and said, this needs to be on a zero carbon trajectory. It was a real push to move just a little bit further across that line from high performance into zero carbon territory. So I think that's, so it's not just net zero, but really looking at the full decarbonization spectrum.
I think it's really been an exciting time seeing what's happening in our industry. We've seen the sensitivity for our personal and professional lives to things happening across the other side of the globe. And so I think there's a heightened awareness of where does our energy come from and how can we reduce our dependence on it that's coming from faraway sources. There's an inherent resiliency opportunity that we're seeing just in the last 3 years. The closer we can produce energy really tightly coupled to a building can make a big difference. Annika, myself, and others, wonderful people in the industry have all been doing a lot of incredible work in this space on building codes and standards. And we're really encouraged that before we start a project, what's the code minimum baseline? Where do we start as the bare minimum? And actually that bare minimum is really increased in stringency quite a bit in lots of parts of the country to the point where it's already driving an incredible discussion about net zero energy. And what we're seeing now is that's actually starting as the target. What does that look like? And then how do we work from there to a executable and cost-effective project?
Yeah, and I would add to that not only was that radical drop in the price of photovoltaic something that all of a sudden net zero became a real consideration for, we work with mostly public clients with limited budgets, but also as the price of solar began dropping, the awareness of what net zero was and the possibilities kind of rose. So they kind of met each other at this magic moment, I'd say in 2015, 2016. And after that, at least for our clients, they saw a lot of benefits beyond, I can mention the BlackRock memo and kind of, the push for net zero, but also the opportunities in terms of operational savings, in terms of investing in systems that actually, work better and reduce kind of operational costs, maintenance costs, labor as well, and for us, because we do a lot of K-12, the educational opportunities, so engagement and building that into curriculum and things like that. So there was a kind of magic moment that has just continued in momentum as things like the BEPS legislation in DC, that push from a kind of regulatory stance has made it more and more aligned with net zero. I was on a call the other day where somebody in DC said, well, this is the last building that we can do that's not net zero, that we have the option, right?
And I want to give a shout out for alternative financing. I think there's so many different vehicles now that our owners don't have to capitalize the installation of, solar PV or other forms of renewable energy on their projects. And if they don't have a tax liability because they're a government or institutional client, a nonprofit, there are third parties who can take advantage of the incentives that are out there, particularly those tax incentives. So these third-party vehicles, these power purchase agreements or community renewable energy facility financing vehicles are a really important part of the process. We just did a 240,000 square foot courthouse and county administration building in Maryland, and we asked the county if they were interested in doing a PV array and through this type of vehicle. And they were so excited about it, and we ended up being able to install PV that will provide about 60% of their annual electricity on site. And they said they were going to install PV now on all of their other county-owned buildings because of this, because it was so easy and seamless. But even for-profit clients, I consulted on a multifamily project where they're installing an integrated PV and green roof system, and it's $1 million array. And they asked me to review their power purchase agreement, and I said, in DC, because of our renewable portfolio standard, PV is like a 3 to 5 year payback. It's really quick. I was like, are you sure you want to go through this third party agreement? Why not just pay for it yourself? The payback's so fast, and they said it's still $1 million. That's $1 million I can invest in the next project. That's powerful. That this is such an opportunity, whether you're for-profit or nonprofit, that there's investment opportunity in renewables right now, that it's very attractive, for third-party investors to get engaged.
Yeah, it's been interesting. You've touched upon a couple points of scales of economics, right? It's no longer a major expense, right? It's starting to close the gap a little bit in economics. I wanted to touch upon the scales of net zero and some of the geographical differences. So, how should building owners and operators be thinking about the scales of net zero? You talked about some urban sites that might not have the ability to fully produce energy, and Michelle, you talked about some kind of limited budgets, but how can we start to think of net zero kind of at a scale of architecture that might be different from one another?
Yeah, I think we have a lot of jurisdictions who have signed on to the Paris Agreement or other targets for getting to zero carbon by 2030, 2040, 2050. And to do that, you need all hands on deck, all buildings on deck. But a very energy intensive building and community resource like a hospital might not be able to do all of their production on site. A zero lot line building might not be able to do it. A tall building, a tower might not be able to do it all on site or within the lot line. And so it's really important to look for community-based solutions, community scale solutions. A school might have more land area than they need, and might be able to generate more energy potentially and sell some of that back to, become a community renewable energy facility or other facility types. And so we're working on a hospital that has a large array on its parking deck and has become a community renewable energy facility to provide free green power for low-income households surrounding the hospital. And so there's these types of arrangements that can really be looking at that community scale or district scale that I think are going to be essential to meeting the urgency of our climate crisis.
Yeah, I think the scale issue is such a fascinating one. Net zero energy is a great concept because you either hit it or you don't at a building level in terms of balance. So there's a point of clarity there that I think is very powerful for the industry. But we also want to make it clear that it's okay not to be able to do this all on the building. As Annika mentioned, laboratories, hospitals, really tall buildings, there's a limit to how much energy you can produce on site to balance that annual consumption. And so as we look at a community scale, there's a lot of ways we can share those resources and benefit from the economy of centralization. A larger system is still going to be more cost effective to deploy than a bunch of smaller systems. When we look at new construction, it's so important to have just the right team on board at the very beginning to really optimize the roof area for renewable energy. There's always competition for HVAC equipment, other things, rooftop amenities. And so getting that on the table at the beginning is really quite important. One of the things we had studied with Sam's team were agrivoltaics and aquavoltaics. And what these are, just sharing land with PV systems. There is a lot of consideration now if you put a utility scale array in the middle of land, is that actually conflicting with other use for harvesting food or other materials? So the more we can share that use at different scales, there's a lot of great benefits. Annika mentioned the beauty of being able to integrate now green roofs with PV systems. That's a really wonderful interrelationship of those two systems that's really happening already today.
Yeah.
Yeah, and I would add that on our prep call, Annika said something about, if you only get to 90% toward your net zero goal, that's still amazing, right? It's an amazing thing to do. And I think it all comes down to sort of taking responsibility for that footprint. That balance you do in net zero design, whether that array is on-site or off-site, really is irrelevant, because you're talking about, just having this mindset of ultra low energy use combined with production, be that on-site or off-site. So I think that exercise and that constant iteration against that ideal is a really, I think it's a source of innovation for a lot of design teams.
Yeah, so it's interesting. We've kind of been touching upon some maybe regional differences. Some folks in the audience might be here in DC, some might be on the West Coast or elsewhere. I wanted to touch upon, some of the regional differences for clients. What regions do you see that are kind of net zero ready and gung-ho about this, or some that maybe are a little more reticent, or maybe even some regions that surprise you?
I mean, I think, here in the Mid-Atlantic, there's just with DC surrounding counties, we have a series of energy codes, green building codes, that have been driving, and I've tracked this, are building site energy use intensity down. And so market rate buildings, I've been watching like commercial office buildings at market rate, go down from the 50s to the 40s to the 30s, and now we're kind of in the high 20s, low 30s already. So we're getting really close to what the New Buildings Institute would say is their median net zero site energy use intensity or site energy demand. And so we're already building net zero ready buildings at market rate construction. It's just now bring the renewable energy on board. And if we can finance that through a third party, through a PPA or power purchase agreement or some other vehicle, then, or through funding through the new Inflation Reduction Act or other resources and incentives, we've really solved the equation. So, but in, the central part of the country, for example, there are some jurisdictions, some utilities that put a cap on how much energy you can actually, generate on site or net meter, maybe 100 kW. There's, net metering is allowed protected by federal law, but they might actually limit how much you can net meter. And so that can be restricting, that can be limiting to whether or not you can truly go net zero.
Yeah, and I think another nuance here, the grid that we have in the United States is very different from one part of the country to another. In the Northeast, let's say in New York City, the emissions factor for 1 kilowatt hour that's generated may actually be about 1/5 that in another state in the Northwest. And I don't want to pick on any state, but it's a reality that we have an interesting fuel mix depending on where we are connected. And so that actually will drive some of the value if we're looking at greenhouse gas emission reduction. We take one of those states where there is a high emissions factor, deploying on-site renewable energy is going to actually make even greater impact overall on the carbon emissions reductions standpoint. Another part of this is, I think, Sam, you had a slide that showed 6 different states will have renewable energy standards that target 100% renewable energy by 2032 or close to it. Some other states may stop at 8% or 10%. And so there's this unevenness that we're seeing that really takes, I think, good awareness and demand from market, from design teams very local to their communities to just bring awareness and elevate doing the right types of calculations and presenting the right data at the right time.
I do want to say after the freeze, the winter storm last year in Texas, that's my home state, so I'm not picking on Texas, but on a personal scale, people who aren't particularly environmentalists, I saw more people that I grew up with who said they were buying solar panels for their home and batteries for storage for the first time. That there are grid resiliency issues that people have been confronted with that didn't give much thought to this, and I think we're going to see more and more limitations. I know that we have now historic investment in our grid, and I think that's a really important part of net zero going forward. The grid has to work both ways. We'll have to feed into it as well as draw from it. But I think that has brought this to a level of consciousness and awareness that we've never had in this country before.
So we've talked pretty broadly, right, about market conditions and some policy changes, but I wanted to shift gears a bit and talk about the kind of the alternative energy production technologies themselves and how we're seeing them used. So what are some of the trends or advancements that you all are seeing, installing, discussing with clients around on-site renewable energy production? And how do you see those technologies working or frankly not working? What are the challenges?
Well, it's fascinating what we're seeing in interest in batteries. And I think we've seen this even in our personal experience with electric vehicles, because there's so much focus on batteries, producing them safely, reliably. Most of the technology that's used right now is lithium-ion based. So there is a lot of discussion about harvesting minerals and where those are sourced, that whole supply chain. But these systems are still relatively expensive, but they're really dropping in price, just like solar panels have also. But what is a limiting factor is the overall capacity. Lithium-ion batteries are designed so you can discharge them and charge them really quickly, high power intensity, but not necessarily for a long duration. So you may size them for 1 hour or 2 hour discharge and discharge. Now, what is a really great opportunity that we're seeing emerging is the use of some other types of battery technologies, what are called redox flow batteries. They do take up more space, but you essentially have large electrolyte tanks, and you actually pump the solution through a device that then generates that electricity. And what you can do is, however big you want your tanks to be, you can actually scale up your battery storage quite a bit. And so that is something we're keeping a close eye on and think is going to create a lot of opportunities, whether at a community scale or entire utility scale. But what's critical and the big consideration with solar is that we can't generate that electricity at night, clearly, when the sun is out. So we need to be able to leverage that energy that's harvested just at the right time. And typically the peak for our grid is really in the afternoon, late afternoon, especially during the summer when everyone's using their air conditioning or coming home and starting to run different pieces of equipment in their households. So this is definitely something 5 years ago, we would look at battery storage and it might have been discounted because the cost of it was really high. And it's actually fairly hard to integrate that type of technology within a building itself. Lithium batteries, if you've all traveled on a plane and don't put it in your suitcase because there is a fire risk. If something happens, you have this concept known as thermal runaway that is very hard to actually control that thermal property of a lithium battery. That's a good thing with these flow batteries, that they don't have that same risk. We'll see how this continues to progress, but with more and more market demand, the price will continue to drop and there'll just be more deployment and then more resiliency within our grid in our communities.
I think as part of the circular economy, we're seeing more in biodigesters. I know DC has a 13 megawatt biodigester at DC Water at Blue Plains, which generates energy for the facility, but also Class A biosolids that are sold to farmers in the region. There's other facilities that are converting what would normally go to the landfill into alternative fuel products. There's things that are taking food waste and converting them to energy, other organic waste into energy. And so we're starting to see more of those types of biofuels and biodigestion, combined heat and power, that type of thing. So is it everywhere? No, but it's certainly an interesting trend that we're seeing. And of course, I think there's some investment, some of that electrification and investment in grid, resiliency in rural America and in farms in rural, America is about wind technology and getting more sources of energy to the grid. So I think we'll see more of that, which won't be as interrelated with buildings, but will continue to clean the grid up and help bring down that emissions factor for the energy that we're using off the grid.
Well, and I would just, I love being on this panel with Annika and Roger, because it's just like they see the whole planet, and meanwhile I'm like, yeah, but on our schools. But I will say that while the advancements in technology are great, especially around batteries, as Roger was mentioning, and I can't wait to go tour some of the biodigesters. A lot of the technology that we use in our schools is not advanced technology. It's stuff that's been around for ages, it's just the intelligent putting together of systems that have been tried and true. Heat pumps aren't, rocket science. Geothermal's been around for ages, and solar panels are getting more efficient, but still the technology is pretty basic. And it's just a matter of getting a right team integrated from the outset toward that goal. And some of the innovations that we see in the projects that we follow and that we do are just smart integration of, say you have a project that requires a backup generator, and maybe instead you can do a battery backup for your solar array, and that's a win, right? It's not going to make the cover of Engineering News or, but it can totally be done. We don't have to wait for the technology to get there. We have the technology already for many types, not all types, but some of the workhorses of our society can be that.
And that's what it should be. It should be tried and true technology. And of course, the best solution is to reduce your loads, reduce your demand, so you don't need a lot of technology.
So I think we've been kind of touching on it's maybe not new technology, but it might be new to the client, right? What are some practical strategies that you've found on projects to help clients or really maybe even help the teams get on the same page? You talked about having the right team at the outset of a project. What are some practical things that maybe you can share with the audience on how do you even do that? What does success look like?
I think the number one successful thing is peer-to-peer discussions. So if you're looking to try some technology that you're not familiar with, find somebody who's doing it already and talk to them about how they have found the experience. I would say that has been the most important conversation changer in our work, has been connecting happy clients with new clients and having them talk it through.
Yeah, a lot of our clients want to see something on a building that's already in service. So touring the building, talking to the building engineer or the building owner, understanding how to operate it, whether it's renewable energy or high performance systems. We've had, start talking about those options early, understand if the building engineers don't know how to operate or maintain these systems. And then we've very early, early SD even, let's bring folks in to do education, get a familiarity with the systems or components we're talking about, and make sure we're on the same page before we continue to proceed with a system design. And I just want to, shout out for a tight building envelope. Infiltration is probably one of the biggest drivers of, of that demand that we need to get down, those loads that we're designing for. And so if we can really early on design a great envelope and really focus on load reduction, then we're winning half the battle. And then maybe we don't need as much in terms of systems and equipment that we have to understand how to use.
Amen.
Yeah, I think there's a theme here of just collaboration and knowledge sharing that's really powerful. And one thing I've found is it's important not to take for granted. Sometimes we assume people may know a certain concept or acronym, and It's really great when we can take a very diverse stakeholder group at the beginning of a project and like tour an actual project or look at data together and just make it very accessible for folks and very comfortable to dig into these things. And a lot of this, as Michelle mentioned, is not really about the fancy technology, but it's how you put it together and integrate it together. And there is definitely also an incredible role with the builder, with a contractor coming into play as early as possible in the process, understanding how these things are built and constructed and any things, especially with like supply chain, that we need to be concerned about. And so the more we collaborate, the more we can actually really be successful.
Another thing is just building comfort with our clients. I mentioned that integrated green and solar. We now are seeing like fully warranted systems. So the roof membrane, the green roof, the solar, fully warranted as a whole package. That's really important to our clients. I mean, that could be a deal breaker if you can't get a warranty for the roof. And so, and then the green roof can actually ballast the solar system, so you don't need roof penetrations. So again, it's something that's actually improving the quality and the durability of the roof. And so we're seeing just a better integration in the industry of how these things are put together, how they're applied to the building, and how they, protect the owner and liability. So all in all, just the whole industry is coming together.
I wanted to pick up on maybe a red flag word that, Roger, you talked about, supply chain. How are you seeing that impact the world of renewable energy technologies, and how do you see project teams and clients overcoming that?
Well, I think on the panel side, if we're just talking about photovoltaics, that piece has actually been okay. I would say anything that's an electronic component outside of that, we have been seeing definitely some supply chain considerations. One of the products that's ubiquitous in our industry is the variable frequency drive, where you can regulate a fan or a pump. Those all have the same susceptibility to microchip shortage that we've seen in the auto industry and other industries. And I think for right now, teams are having to be very flexible. So I think that does interrelate to the application of technology, because some of these can be emerging, and there may only be one or two companies that can deliver those products. So vetting that out, develop a relationship with a manufacturer, understanding their pipeline and their research program, I think can all be helpful for just the whole team being very transparent, understanding risk factors for a project.
I don't know about others, but sometimes we're getting submittals while we're still in early CDs because our contractors are trying to buy this stuff out, very early. We don't even have a permit yet, but, you have to just keep moving things kind of up in timelines so that it's on the site when you need it because of these supply chain interruptions and delays. So, everyone's finding solutions because we have these challenges, but you have to keep moving project forward. So some things are coming, you're like, why am I looking at submittal for this? We're not even, we don't even have a permit yet. It doesn't matter. You just, you have to work with what you got.
I wanted to make a quick plug that as we're having this discussion and people are, thoughts are coming to mind, please enter questions in the chat box and we'll address those at the end. Roger, did you have something else to say?
Well, something related to supply chain, and this is not necessarily about availability, but market demand, heat pump technology. Actually, there's been so much interest in it in the last 3 or 4 years that we are seeing more scarcity. We are trying to apply air source heat pump technology to help with decarbonization with some of our clients. And this equipment, we may have in the past said, oh, if it's like 16 weeks or 20 weeks, seems like a long time. Now it's creeping up to almost a year for certain types of products. So it's just something everyone just has to be very flexible and agile. It's testing teams' own resilience to react to the conditions. But at the same time, it's, I think, gratifying we are seeing this demand driven by people's focus on decarbonization.
Yeah, I would say our experience is we're not seeing any more craziness around renewable energy stuff than we are around the rest of the visions.
Yeah. I'd say the good news about like a solar array, right? It goes on top of the building or on top of the garage. If it's delayed a couple of months, it doesn't matter. The building's in service. You put it on when it gets there. It's not the end of the world. It is more challenging if it's something that that the building needs to function. but so it's usually one of the last things that goes on the building anyway. So it's a bearable, a tolerable delay if it happens. It shouldn't be a make or break issue if there is a delay.
Well, it sounds like we're coming up with ways to get around supply chain, and just remaining calm might be the best. I wanted to talk a little bit about incentives and offsets. We talked about the scales of net zero, right? Urban versus suburban versus somewhere in between. I wanted to talk about and ask the panel, what do you see the role of offsets being on projects? How should clients be approaching offsets, and how do you see them changing in the future?
Yeah, I think they've been demonized, right, as a cop out, and to some extent, things like Greenie certified RECs are things that have allowed renewable energy to expand so rapidly because they cover additionality. They are for new renewable energy programs. You can't buy past renewable energy generation. This is to invest in new renewable energy, but it should be the last resort. And a lot of net zero building programs sort of discount them, right? Like you have to do your on-site efficiency first, your on-site renewable energy first, and you don't get full credit for RECs. It's not like you can just do an inefficient building and buy a bunch of RECs. So I don't think they should be demonized. They are part of the larger solution. I don't think we have the ability to have enough RECs to buy our way out of the climate challenges that we have. There won't be enough RECs to solve everyone's problems. So people shouldn't look to that as a solution, but don't demonize them. I do think investing in community renewable energy is a really valuable solution. So there can be some large scale, as we've talked about, community renewable energy facilities. You're putting renewable energy on your local grid, and that can be a semi-large scale on a big box store, on a school campus, on some other type of facility, and that can be a really valuable thing. Cleaning your local grid, helping offset bills for low-income families, et cetera. I think that can be really valuable. So we have to how are we defining these things? But I think it's okay. It doesn't all have to be on site, as we said.
And then maybe lastly, and before we open it up for questions, I wanted to touch on, who owns and pays for first cost of ownership for some of these things. Traditionally, we've seen that as a high barrier to entry for some of these technologies, but as we talked about through this panel, those costs are dramatically decreasing, but there's still a delta between traditional systems and maybe alternative. How are you seeing a client's approach that? How are you seeing the appetite for that, and maybe some regional differences?
And I would say in our public work, we've seen a shift from districts who were purchasing their own arrays at the beginning, now doing PPAs, just because of, as Annika mentioned, having the flexibility to invest that capital in other projects. And in terms of technologies used in the projects themselves, like I said, they take advantage of incentive programs, and because the conversation around heat pumps and things like that have changed so dramatically, there's usually not a huge premium for efficient systems, with the exception of something like geothermal. So we're seeing them just wrap that into their normal construction costs.
We're definitely seeing some difference in incentivization depending on the part of the country, and that can make a big difference. I think what's on people's mind right now is definitely the Inflation Reduction Act, because there is so much within it. Lots of different organizations are really doing a deep dive to see how it's going to impact our industry at different scales. But I think it's encouraging. There is a tax deduction that's been around for a while that's actually gone from $1.80 to $5 a square foot to support energy efficiency measures. And I think that's super exciting. What's even more exciting is the federal government or the government or nonprofits before is a little bit more challenging to exercise this particular credit. But now there's a provision that allows the team to pass through that credit to the architect or engineer or contractor as they're implementing some of those measures is more flexible. This is all still new, so everyone's still, I think, really getting the full extent of it. But it does signal, I think, to the industry where things are headed and what we need to focus on collectively in the industry moving forward.
Yeah, and the 179D tax credit is really exciting because for new buildings, they're looking for that 25 to 50% reduction from the latest ASHRAE 90.1 standard. But for existing buildings doing deep green retrofits, you're actually compared to that building's past performance as your baseline. So the easiest path is existing building retrofits. And so it actually encourages, I think, investment in our existing building stock, which addresses the embodied carbon issue. And for jurisdictions who do want to adopt building energy performance standards or other legislation policies to address that, this is a huge chunk of money to help, align with those types of policies to help incentivize building owners to invest in those deep green retrofits. There's also then incentives for renewable energy, for energy storage, and for electric high efficiency equipment and appliances. And so that will buy down, I think, the premium for heat pumps, ground source heat exchange, and other types of systems that help us decarbonize our buildings, new and existing. So it's really exciting, to see this type of just huge pot of resources to help us make this investment in new construction and existing buildings.
Well, I think that's a good kind of pause point. And again, I'll make the plug. If you have questions, enter them into the chat box. I see we have quite a few coming through. So I wanted to follow this thread around maybe economics. Can you share any information on cost, like cost per square foot for installation, maybe for some of these systems that you're seeing?
All I can say is we really try to focus on load reduction so that you can right-size systems, and we look for cost-neutral strategies. So, I don't want to put a dollar on any system because we really try to not have a cost premium to do high-performance building. And then again, the renewables you can offset through third-party financing. But if you focus on load reduction, you can, reduce the system size, and then you can find a cost-neutral solution.
There's quite a few questions around examples, so maybe this is more of a broad question. Can you provide one or two examples of commercial buildings? This question was around DC, but maybe even in other locations where net zero energy technology was applied and completed.
Yeah, there's a Arlington, there's a net zero school. There's the American Geophysical Union is a net zero retrofit. We've got lots of, there's I'm trying to recall the pharmaceutical company that's up in Silver Spring, but there's several.
The Unisphere project. Yeah.
That's right, yeah. I mean, there's several buildings around DC, both new and existing, that have done net zero. And around the country, obviously. And MBI has a really good inventory of net zero buildings, the New Buildings Institute, if you go to their website. And what's great is they're in every climate zone. And it's all building types, private sector, publicly financed, and across all the different sizes, even large buildings. So it's sort of like you can't list them all.
Yeah, one thing we were involved in is developing a decarbonization playbook for NYSERDA, the New York State Energy and Research Development Authority, and we worked with 4 different of the largest real estate developers in New York to really just document the whole process of evaluating existing building and figuring out what's the right types of technologies and measures to really reduce energy use. And this is all shaped by the energy performance standard that's in New York City. That's called a Local Law 97. And this particular approach uses emissions thresholds for greenhouse gases that continually decrease in intensity allowance. And there are pretty large fines that go with programs if someone doesn't comply. And it's really driven the real estate market to be quite aggressive with how they're looking at overall retrofit opportunities. So it's not so much on the alternative energy side, but is making a building much, much more efficient to get back to this idea of getting as close to possible and be able to balance, particularly at a community scale. And we're seeing that just really accelerate, I think, in cities all across the country. And that serves as just good inspiration, more knowledge sharing, more case studies that people can draw on moving forward.
Pam, can I ask Roger and Annika a question? Am I allowed to do that?
Absolutely.
Okay.
Absolutely allowed.
All right. So we've been using a couple of terms within this webinar interchangeably. We've talked about net zero energy. We've talked about net zero carbon. We've talked about zero carbon. All of our clients seem to be focused mostly on net zero energy. So question for you all is, do you see a difference in outcomes from clients that pursue net zero carbon or zero carbon versus zero energy? Like, is there a difference in those projects?
One of the distinctions I know is with zero carbon, there's no combustion on site. And so that's one issue. Now, again, that would be zero combustion. You could do all the generation of energy on site or some on site and off site. We have a zero carbon inpatient facility in Oregon, Oregon State. All of their purchased electricity is hydro. And so that's a zero carbon facility, but there is some off-site energy purchased. But zero energy doesn't specifically preclude on-site combustion, but you would, generate enough energy to offset whatever energy consumption you have. So I'd say that's the main difference I would see. And generally, net zero has been defined historically as on-site balance.
I think the other side we're seeing, Michelle, in that net zero carbon is also the embodied carbon piece is now being linked to it. So before we just focus on operational carbon, but now we are paying a lot more attention to structures, and then now even all the building systems, furniture, that's just going to continue to exponentially grow in interest and the good quality of data that we have available over the next 10 years. So.
Be very confusing. Ed Masria started calling that carbon positive. But technically, one would hope that you're going carbon negative, right? There's a lot of confusion around those terms as well.
And are you seeing any difference for those clients who aren't going zero carbon or energy, but are tracking, EUI versus carbon intensity? Is there a move where in places with a dirtier grid where they don't want to move for full electrification because it comes with, if you get a dirty grid going electrifying, but if you're not doing on-site solar, means that you're increasing your emissions. Are you coming into any of those conversations yet?
Well, the thing with the electrification and with natural gas is that in addition to the combustion component, what we found, they've been surveying these cities, especially older cities with older infrastructure. There's fugitive methane leaks, thousands and thousands of fugitive methane leaks, and that in the short term, natural gas and all of the methane and all of the chemical compounds that come along with it are like 86 times the climate impacts of carbon. So in the near term, it's actually has a much more significant global warming impact, as well as some really toxic human health impacts. So all of the stories we heard about, natural gas being cleaner energy than what was coming off of the dirty grid, is actually kind of flipped on its head. And so really the drive towards electrification may be around decommissioning some of these older natural gas networks.
I think the beauty of what we're seeing is that when a client is interested in carbon, we track energy too. So you can easily calculate multiple metrics simultaneously. And I would have to say that we don't have the same intuition with the greenhouse gas emissions intensity factor like we do site energy use intensity. That metric's been used for a really long time. So when we say schools designed to 15 or 20, it's something, at least within the industry, there's a little more knowledge of. Right now, if I said, what's a low carbon intensity building factor, I don't think one could name that easily. So I think over time, we'll get a better sense of that. We often do convert to what's the equivalent number of average cars that we're taking off the road and things like that. And that using that as a parallel metric is very helpful with communicating intent. But a good thing is a lot of these calculations are just post-processing. There's a lot of other work that makes it easy to calculate at the end of the day. So we just try to track multiple variables and just make sure they're all tracking. They have a goal and they're tracking in the right direction.
Well, and speaking on maybe some of the ways we communicate to clients or the ways that we share information about alternative energy, there's a question around objections. what are some client objections you have encountered when proposing more sustainable design, or materials, and how have you responded?
I think there's always the fear of if it's not in alignment with operations and maintenance protocols, maybe if you have a campus and they're typically using different systems, that it's more time and more effort for their maintenance staff. Those are always issues. Or that it won't be maintained properly and therefore maybe break down and things won't operate properly, buildings won't function properly, that it could compromise safety. And those are legitimate concerns that we have to address, and it could take some training or other engagement. And sometimes you don't go with your first choice of a system because it is too complex and it does deviate too significantly from the rest of the campus.
Yeah, I think going back to the earlier question just about the cost of these systems, that clearly is not something that we can ignore. At the end of the day, those capital resources, the money we have available, has to be used wisely. And what we find is if there is a technology that maybe to a particular location hasn't been used frequently, some of the estimates you get can be higher, right? Because people are trying to smartly control their risk in deploying and executing a project. And that's why the more we can benchmark, share data within industry, it's going to really help us quite a bit to reduce that discomfort, because we can definitely kill good ideas quickly just because of the natural complexity or lack of clarity in design just naturally that happens at the beginning of a project. So a lot of good ideas, we can start with 15 ideas and you whittle down too quickly. So we try to drive an engagement process that avoids what we call cost prejudice, because sometimes we do go into projects and we think a particular technology is not going to be affordable, but we have to look at it real time and then make good decisions from then.
And look at the intersections between, an example I'll give on one of our Arlington schools is we invested in more insulation and better air tightness in the envelope, and that was a $170,000 premium compared to a code compliant envelope. But because of integrated design, we were able to downsize the HVAC systems and the geothermal field, and it was actually a savings of $100,000, right? So if you're looking at a cost estimate and you're like, well, wait, how much for that envelope? We can do it a lot cheaper this way. Or if you don't have a team that's looking across the sizing of equipment based on the actual conditions and occupancies and instead something more abstract, or you can end up paying more than you need to, and things look more expensive than they are because there's not that interconnection, which, going back to Roger's point, when you're in SDs, it's hard to have that kind of fine pencil. You're drawing more with a big charcoal, right?
But you do need an integrated cost estimate, right? You can't look line
exactly.
item. You have to have an integrated cost estimate. Yeah.
Exactly. And then I would say, just one more challenge in having the conversations is particularly with clients who don't do a lot of buildings or don't have sophisticated kind of planning aspects, or this is the one building they're building in the next 40 years. There's always this battle between what's the minimum I can build for the maximum amount of square footage, and not really having in their minds the kind of total life cycle cost of the building, and that if you build it to just code minimums, then you're going to end up paying a lot more and maintain a lot more. So there's a lot of scaffolding with those clients and kind of building them up to understand the whole investment that they're making in that asset.
Well, at the top of the hour, but I wanted to give everyone an opportunity to maybe say, what's your parting thought on this topic, or maybe your inspirational quote. I'm not sure, but I did want to say that it seems like there's a lot of interest in this topic. So we can always do a part 2, right? We can always continue this conversation virtually. So be on the lookout for that for future Masters series from HIT. But I wanted to go kind of around the room and maybe, what's your one parting thought on this?
Well, we should definitely do this again. That's definitely one parting thought. And I think anytime we engage a nice cross-section of folks from the industry with a diverse audience, we always, I think, learn from each other. And that helps us all collectively be more successful in the future.
I always just say we shouldn't say no for our clients. We should give them a chance. So don't assume the answer is no. Present the ideas and the opportunities to our clients. Don't assume that they won't go for it.
Love that.
And I would just add to that, don't be scared. Okay. Like, it's achievable and it's interesting and it's not something scary. It can be done today.
Great. Well, and you all are a testament to that as amazing subject matter experts in this field. So thank you so much for joining us today, and thank you to our audience members for submitting such interesting questions, and be on the lookout for a continuation of this conversation. And thank you, everyone.
Thank you very much.
Thank you.
Bye-bye.
Thank you.